So this video is to help you to learn more about mechanisms. You've already studied one mechanism, free radical substitution, which is unique. The other mechanisms you are going to use will involve curly arrows. So you're going to have to start to get to like them. So the first rule that you need to be able to employ are arrows will start at either a lone pair of electrons or halfway along a covalent bond. What you have in these two examples is you have chlorine bond breaking, and a nucleophile, represented by Nu-, reacting. If you notice, in the chlorine example, the arrows started from halfway along the bond, and for the nucleophile, it started from a lone pair of electrons. Now, if an arrow starts from a lone pair, a bond is formed between the two atoms. If we look at this example, the nucleophile Nu-, the lone pair is starting from that lone pair, it is going towards the C+. What that will mean is there will be a bond which will form between the Nu and the carbon. Now, if an arrow starts from halfway along a bond, that bond will actually break. So in this example, going back to the chlorine breaking apart, you will see that in the products, the chlorine's atoms are now separated out. The one on the left has become positive, the one on the right has become negative, which we'll understand in a second. But what you need to understand is that the arrow has started from halfway along the bond, so the bond breaks. Now, the atom where the arrow finishes becomes one more negatively charged. The arrows represent the movement of a pair of electrons. So where the arrow ends up, the head bit of the arrow, that atom will become one more negatively charged. If it was neutral to begin with, it will become negative. If it was positive to begin with, it will become neutral. The atom where the arrow starts becomes one more positively charged. The reason being is the electrons are moving away from that atom. So if that atom was neutral to begin with, it will become positive. And if it was negative to begin with, it will become neutral. So if we have a look at the example here again of chlorine reacting and breaking apart its bond, you can see that the bond breaks because we've drawn an arrow from halfway along the bond. The atom on the left is really where the arrow starts from, so that becomes positive. The chlorine atom on the right, that's where the arrow ends up, that's where the arrow head is, that becomes negative. If we look at a slightly more complicated example here, what we have is a nucleophile with a lone pair and a minus charge attacking a carbon with 3 bonds and a positive charge. In this example, the arrow starts from the lone pair on an Nu-. That means a bond will now form between the Nu and the C, and the Nu atom will become one more positive. Where the arrow ends up is on the C+ atom. It was positive to begin with, but the arrow ended up there, so it becomes neutral. So we end up with an NuC, or an Nu joined to a carbon. Now, another very difficult example is you have this bromoalkene reacting. Now, sometimes we need to push arrows around a little bit. So if we look at the original thing, we have a double bond, and an arrow is going from one of those bonds to another position, and then there is an arrow from halfway along a carbon to bromine bond onto the carbon. What that actually means is the original double bond will break and just leave a single bond. A double bond will form where that arrow ends. The second arrow shows a bond between a carbon and a bromine starting from halfway along, so that bond will break. So they're the two products we will end up with. Now you have to think about the charges. The arrow really ends up on the bromine, so it becomes negative, but where the arrow really starts on the original molecule is the leftmost carbon, so that will end up being positive. Now, if you can apply these simple rules about mechanisms, you will not go far wrong.